Most of our climate here on Earth has been friendly for the last few thousand years. But during most of the past 3 million years, the Earth has been much colder than it is now. And the regions where most of our food comes from were too cold to grow any food at all. Scientists have recently discovered that there has been a long series of recurring ice ages in the last few million years, with relatively brief periods of warmth in between. Each of these ice ages has lasted about 90,000 years on the average, while the warm interglacial periods between ice ages have averaged only about 10,000 years. This long cycle of major ice ages, approximately every 100,000 years, suggests that we can expect another one sometime soon. But what does soon mean in ice age time? And how much warning are we likely to have? And is there anything we could do about it even if we had some warning? Recent studies of ancient ice deposits and of underground layers of pollen from trees that lived 100,000 years ago suggest that last time, the final transition from a warm to an ice age climate happened incredibly fast. Not over thousands or even hundreds of years, but in less than 20 years. When the shift occurs, the climate in many regions of the Earth cools very quickly. Fruit and nut trees that need warm weather no longer grow in many temperate regions, and they are replaced by the kinds of trees now found only in areas like northern Sweden and Alaska. The glaciers will take many thousands of years to reach their maximum point, but the climate cools so suddenly that agriculture almost instantly becomes all but impossible in most regions of the Earth. Some recent evidence suggests that we may now be more than halfway through such a rapid, perhaps less than 20-year transition period, and that we may be less than 7 years away from the beginning of the next ice age. What could possibly cause a cycle of ice ages which recur every 100,000 years? Up until recently, many scientists have believed that the major ice ages are caused by very small changes in the Earth's orbit over tens of thousands of years. Changes which have minute effects on the amount of sunlight reaching various parts of the globe. Some of these orbital movements do seem to cause relatively minor fluctuations in ice cover on the Earth. But the small variation in the Earth's orbit around the Sun, which very slightly narrows and widens on a 100,000-year time frame, produces changes in sunlight which are so minute, on the order of 0.5%, that many scientists now feel that this is not likely to be the cause of such enormous phenomena as the major ice ages. This orbital theory assumes that something has to cool the Earth in order to bring on an ice age. But Sir George Simpson, who was the head of Britain's Royal Meteorological Society, had a different idea. 50 years ago, he published a paper in which he suggested that some source of increased energy would be needed to move the huge amounts of moisture which build up the glaciers of an ice age. Presumably, most of this moisture comes from the oceans. But where would the increased energy come from? Sir George thought that the sun's brightness must change in some cyclical way over tens of thousands of years, but there has never been any evidence for this. Now another scientist has come up with a more plausible source of that energy. John Hamaker is a mechanical engineer trained at Purdue University who has been studying climate from a very multidisciplinary perspective for the past 15 years. Hamaker believes the energy to build up the Ice Age glaciers comes from a greenhouse effect. 100 years ago, when industry was spewing out the dirty waste products of coal, and then oil burning in great quantities, scientists began theorizing that the excess carbon dioxide from such massive burning of long-buried fossil fuels would trap additional heat from the sun and cause a greenhouse effect, which would eventually warm up the Earth's climate. Since we've been burning fossil fuels in enormous and ever-increasing quantities ever since, some climatologists have theorized that a greenhouse warming will eventually warm the Earth substantially, and that this would eventually melt the polar ice caps, which would raise sea level and flood coastal cities all over the Earth. But carbon dioxide, CO2, has been dramatically increasing in the atmosphere for more than 100 years, and there is little evidence of any global warming in all this time. In fact, Northern Hemisphere winters have been colder during many of the last 15 years than in all of recorded history. Florida citrus crops used to freeze about 1 year every decade. They froze 4 of the 5 years from 1980 to 85. New records have been broken over and over again almost every winter in the past few years. John Hemaker points out that the greenhouse effect has to occur most strongly in the tropics, since that is the area which already gets the most sunlight. The poles in higher latitudes, which get relatively few of the sun's rays, they're even dark much of the year, should be warmed very little by a greenhouse effect. When the tropics heat up and the poles don't change much, the temperature difference between these two areas of the globe increases. And when that occurs, any meteorologist can tell you what will happen.
It might very well be that the number of hurricanes would increase, and the number of tornadoes, not only will they increase, but the intensities might be greater.
In fact, hurricanes and tornadoes seem to be increasing dramatically in the last few decades. Some of the difference may be due to more complete reporting, since there are now more people to spot such weather extremes and report them. But the huge increases in the number of tornadoes reported seem substantially greater than one would expect from a slowly increasing population. As the greenhouse effect heats up the already warm tropical oceans, additional water is evaporated, which forms more clouds. Some of this extra moisture gets picked up by the increasing wind systems that have developed and is moved far away. Hemaker believes that this process is responsible for the excessive rainfall the Northern Hemisphere seems to be experiencing in the last 10 to 15 years, which has caused some rivers to flood severely. And that this increased rainfall is what has caused some lakes to rise to record levels in recent years. This is Lake Michigan, which has begun to overflow its banks into parts of Chicago's lakefront neighborhoods. And this is the Great Salt Lake, which now covers the railroad tracks that used to run by it. As some of the new moisture-laden clouds are driven to high latitude and polar regions, they precipitate out as snow and ice, building up the polar glaciers. The average Northern Hemisphere snow cover increased enormously from 1967 to 1975. Since then, the area covered by spring snow cover has again reached record levels, freezing newly planted crops and turning millions of peaches and other fruit into ice cubes. Some scientists now believe that simply by producing more clouds that block the sun, a greenhouse effect makes the Earth colder rather than warmer. Others believe that a sustained increase in cloudiness, whatever its source, could lead to an ice age.